I guess let's give this a go again. Taking up Unit 1 A7, a little bit different method I'm using here, but you guys, let's see what's going on here. That is going to go there now. Oh. All right, here we go. So first you want to write a single power and then evaluate. So 5 is your base, and then how many 5s are there? There's 4, and then you just throw that in the calculator, or tell me that 5 times 5 is 25 times 25, which is 625. I can talk about squaring numbers later. Write an expanded form, then evaluate is minus 2 to the 5. So minus 2 to the 5 is minus 2 times minus 2 times minus 2, and we'll do that 5 times. And if you want to know the size of the number, whenever you have a negative involved, you're going to go back and forth as far as positive and negative. So if I had negative 2 times negative 2, my answer would be 4, and negative times a negative is a positive. My next answer, if I had a negative 2 in there, so negative 2 cubed, would make it 8, and I have an odd number of negatives, so that'd be negative 8, and then one more would take me to positive 16, and then finally I'd end up with negative 32. Okay, so that's negative 2 times negative 2 times negative 2 times negative 2. We'll talk more about negatives with the final question. Over to question 3 now. Write as a single power. So when you have a base like this, that is a variable, you just leave it. You can't evaluate. You just write it like it is, like that, y. And when you're multiplying exponents, you add the powers, and you get y to the 8. Okay, and again, that's because you have 5 y's, and then you have 3 y's, you have them in there, and together you have 8 y's. So they're all multiplying, and that's for a multiplication question. When you have a division question, you'll subtract. So if I had something like this, y to the 5, we'll do this later, y cubed, you would have y times y times y times y times y over 3 of them, and then you end up with y squared, so you would just subtract the powers. When you have a power of a power, what you're saying is, can you please square or cubed 3 squared? You can say please if you want, I did. And 2 ways to look at that. One potential answer would be to square the 3 and then cube it. But the other way to do it would to say that when you have a power, what you'll do is multiply the 3 and the 2 to get 6. Because you have 3 squared times 3 squared times 3 squared. So together that is 3 times 3 times 3 times 3 times 3 times 3, and altogether you have 3 to the 6. So play around with that if you don't believe me, and then you throw that in the calculator, and it's 9 times 9 is 81, times 9 is what, 729, I think. So those are questions 2 and 3. So you can always use your calculator for that. Okay, you'll be allowed to have them. There's either, we're always kind of on the fence on if we allow calculators or not, and on tests. I think some schools get rid of them. They kind of ban them, and one of the reasons is now calculators can do a lot of work for you. So there's you're one step away from having a calculator or a phone that can just scan your whole test and get perfect for you. So schools and universities are getting away from using calculators. We haven't done that yet at our school. I know one teacher, for a test she's doing today, is giving grade 12's multiplication table, like an old school multiplication table. So when they need to multiply numbers, they can look it up on the table so they don't make mistakes. And then there's no iffy stuff about calculators. Anyway, each of these is the power of 10. Very simple here. All you do is count the number of zeros and put that there. Okay, so that's 10 cubed. This would be 10 to the 5. So 10 times 10. So 10 is just 10 to the 1. 100 is 10 times 10. So 100 is equal to 10 squared. And then if you continue the pattern, you'll notice that the number of zeros equal the exponent here. Write each as a single power and evaluate each power. Be sure to show your work. What you're going to do here is 3 plus 1 is 4. Now, if it says show your work, show your work. So what I would do here is I could show this. 3 plus 1 is 4, and 5 to the 4, and then 25 is 625. Squaring numbers is a lot of fun. So I can show you real quick if I haven't shown you before. I'll just show you right here. If I went to square 25, okay, so 25 squared, 625, right? I think that's right. So we're gonna go through that real quick, show you how to do it. 25 times 25. What you can do is you can actually make a giant square that is 25 by 25. So let's take it back a notch. 3 by 3 or 3 squared is 9. You count the number of squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? You do 10 by 10, you can keep going. And 25 by 25 is a big square, and that might be a hard thing to do in your head, but it's not that hard. You can amaze your friends. If you do a lot of math things at home, you probably won't have too many friends for long, but anyway, we'll give it a shot. Okay, so we can break 25 into two pieces. You can have 20 and you can have 5 and 20 and 5. So instead of, so I'm 20 long and I've cut this length here to 20 and 5, and this one is 20 and 5. Okay, it's not a magic trick, I'm just showing you what I'm doing. So if I look at this box here, this is now a 20 by 20 box, right? And this is a 5 by 5 box. And then I have two rectangles, and each of those is 20 by 5 in length. So this is 20 by 5 and 20 by 5. So if you can add up all four of those quadrilaterals, okay, the two boxes and the two rectangles, you can add up, you can find out what 25 times 25 is. So you might know what 25 times 25 is, but I'm just going to show you what I would do in my head is I would go 20 times 20 is 400, and that's not that hard, right? Because it's always you're going to have 2 times 2 is 4, and then add a couple of zeros, right? So 400. And then 5 times 5 is 25. So then what I do in my head is I go 425, 425, and then you're going to take these two pieces, which each are 100, and you'll add them up. So you're going to take this rectangle and double it, so 200. And you add that up and you get 625. So for example, you could probably do something like 91 squared in your head. It's not that hard, right? What you're going to do is square that. You're going to go 90 squared, which is 8100. So 8100. And 1 squared is just 1, so 8101, 8101, 8101. And the two rectangles are 1 times 90, so 90 each. And you're going to add them together. 90 plus 90 is 180. And in your head, you can do this whole thing. Okay? And I bet you can do it. I don't know if that's right. Well, let's pretend it's right. Okay? So I bet you can do it in your head. I think that's right. Okay, so try it. Okay, but let me give you a little advice. When you try it, start with numbers that have low second digits. High second digits will require a lot of carrying. Okay, so if you go with 67 instead of 63, it might be a little difficult. So try 61, try that sort of thing, and then use your calculator to check. Okay, so that's kind of neat. Next up, where am I? Back to the test. Dividing, so 12, subtract 10, 2, 144. Okay. Minus 2, you got here, what you're doing here is you're adding. Okay, so it's minus 2 is your base. So don't get confused here. A base is a base, x, y, z, 2, 5, 9, minus 2, 1/3, whatever you want. It's going to be a base like that. The base is a base, and the same rules apply. When you multiply, you add, so 4 plus 3 is 7. And then you'll go 2 times 2 times 2 times 2 times 2, and your answer will be a negative 2, 4, 8, 16, 32, 64, 128. I believe is 128. And it's negative because it's odd. The power's odd. So you go back and forth with your signs. The last couple questions. This one here is a little bit more work, but I find these kind of fun. Hopefully you do too. And if you didn't get this right, I'm sure you will figure it out in a bit. Let me change to purple. And here we go. This guy here. What I would do is clean up the top and clean up the bottom separately. So I would say these are multiplying the top. So I have 3, 4 plus 6, and on the bottom you get 3, 2 plus 5. Okay, so what you're doing is you're multiplying, you're taking this entire numerator and dividing by the entire denominator, and I would like to simplify the numerator of the denominator. You don't need to. You can say that I have 3 and to the power of 4, and I'm adding to it 6, right? Because I'm multiplying. When you multiply, you're going to add those powers, and then you're dividing by 2. 3 to the 2, so you're subtracting the 2, and you're also dividing by 3 to the 5, so you'll also subtract 5. Be careful, a couple of you added the 5 on the end there, right? But you're dividing by the entire numerator. But if you do it this way, you should get the same answer. If I did it the way I did it above, you're going to get what? 10 subtract 7 is going to be 3 to the 3, okay? And this one, if you add the tops and then add the exponents on the bottom, you'll get that. And now I have a division question, and that will also be 3 to the 3. So you end up with the same. Here, you don't have to do anything with it. You can do it again like I did up top, but I would like to do it where I clean up the numerator, or the denominator, sorry. So my denominator will be 8. Okay, so remember, you're multiplying these two together, then you're going to divide them here. Okay, that's what the route I'm taking, which will end up, negative 5 to the 4 will be the final answer. Finally, at the bottom here, or sorry, the last question here, question 3 slash, oh, sorry, right here, sorry, 3. Hang on, let me try that again. That guy there, you're going to have 3 squared 2 times 5, it's power of power, so you go 2 times 5, 3 to the 10. And again, we're not evaluating, we're just leaving it like that. So I got excited about number 4 because of the zeros. So same rules apply, right? So don't get excited. 0 plus 4 is 4. 1 plus 3 is 4. And then I have a division question, and it's 4 to the 0. 4 subtract 4 is 0. And that would, in fact, be 1. Okay, but we're not supposed to evaluate. So this, it says leave in power form. So I wanted this as an answer, 4 to the 0. Okay. And again, if you did it in one step, 0 plus 4 minus 1, subtract 3, you're still going to get 0. And that is the last question, except for this one here where you have to explain the difference. So the difference here, let me just go over this. A little bit important is this sort of question that you'll see over and over again, or I'll give, math teacher will give you over and over again, is a question like this, where you're asked the difference between -3 to the 4 and -3 all to the 4. So there's a difference because of the power being on the outside of a bracket, and in the first case there's no bracket. So what's happening here is this: the first example is the negative of 3 to the 4. So you get the negative value of 3 times 3 times 3 times 3, and that'll be 81. So that answer will be negative because it's telling, the way that's written, it really is more like this. Okay? The negative of 3 to the 4. The power is not on the negative. Here the power is on the entire number, and the number in this case is -3. So that's your base. The base is -3. Here your base was 3. The second example, your base is -3. So -3 to the 4 is -3 times -3 times -3. So that would be this. That was a 3. Okay, and you're going to multiply those out. You get 81 still, but because you have an even number of negatives, you'll end up with plus 81. Okay, so that's the difference between the two. Anytime there's no bracket, the answer is automatically negative. Anytime there is a bracket, the answer will be negative if the exponent is odd. If the exponent is even, your answer will be positive. So it's a little trick, not trick, it's a little thing to remember if you like. So I hope that makes sense. That's your quiz. Good job. If you have any questions still, come and talk to me or send me an email and I can send you one back. Take care. Bye.